Okay, we're back. We're live. We're here on Wednesday. The most important thing that happens on Wednesday, for sure, is Hawaii, the state of clean energy. Why? Because Hawaii is the state of clean energy, and because we are trying so hard to use our renewable resources, to make it work and get off fossil fuel. And we study this, and we think about it, and we talk about it, and we argue about it, and we try to make little steps to get there every day. And ThinkTech wants to cover this, and so does the Hawaii Energy Policy Forum, which supports this program. Anyway, so today we're going to talk about cooling our buildings with Honolulu Seawater Air Conditioning. Let me call that HSWAC. Do you mind me calling that HSWAC?
We do it all the time.
Okay, that's Greg Wan. He is with Honolulu Seawater Air Conditioning, and he's been, responsible for making it happen. Is that a fair statement?
One of the people responsible, yes.
Okay, all right.
That's a fair statement.
No pressure.
No. There's a lot of us, but.
Okay, we'll ask you about that. And for the moment, we have Hawaii Energy in the negawatt moment, because we could not possibly do Hawaii, the state of energy, clean energy, without the negawatt moment. And the truth is, and I've been thinking about this lately, is the best moment spent, the best way to get off fossil fuel is none other than not using electricity. If we do that, it's like that doesn't cost anything.
Absolutely.
All you got to be is disciplined. So Carolyn Carl is here, and she's with Hawaii Energy. And behind her, whispering in her ear, is Rob DeVerturta of Hawaii Energy. Whisper, say. He's waving, but I don't hear him.
Aloha.
There he is. Okay. Carolyn, I know you can do this by yourself, but if you want to take advice from Rob, it's okay.
Oh, I learned to stop doing that a while ago.
So what kind of tips and tricks can you give us today, Carolyn?
Well, we're the Energy Conservation and Efficiency Program for Hawaii, Honolulu, and Maui counties, and we are here to provide information and rebates about how to save energy. And a little while ago, we did our first round of energy saving tips for the summer, and now we're in full swing in July, and it's hotter and getting hotter. So we wanted to talk about some other energy
Greg knows
saving.
this.
Yes, absolutely. I have some other good tips for the home. The first thing I wanted to talk about was our rebates for solar attic fans. Now, I don't know if you've ever heard of solar attic fans.
No, tell us.
But these are a pretty cool piece of equipment. It actually doesn't use any electricity. Uses the sun's power to draw heat out of your attic in a solar fan during the day when it's the hottest. It helps you reduce your cooling load in your house, and we actually offer a $50 rebate for purchasing a solar attic fan.
Where do I get one?
You get one. You actually can give us a call. We can put you in touch with a licensed contractor that will be able to install
Oh,
it
it has
for
to
you.
be installed.
It does need to be installed, yeah, because you're cutting into the roof. And
Does it
whatnot.
require electricity, or does it operate independently?
Operates independently. So you're basically sucking out the warm heat during the hottest parts of the day when the sun is shining. Typical.
Wait.
Yeah.
I want to know about it. So you got to punch a hole in the roof for it.
Yeah, you do.
And then what do you put outside in the top of the roof?
There's
that
a
makes
vented fan
a vented fan.
with a solar panel on
And
it.
the solar panel creates a little electricity,
to move the fan.
and it moves the air up out of your house and into the atmosphere.
That is
out of your house.
exactly correct.
Okay, how
warmer-
wide is the hole?
It depends on the size that you're looking to cool. I'm sure some homes are a lot bigger than others, so it's sized appropriately to ensure the equalization of pressure and all the important things for the space in which you're looking to cool. But it's vented down into, through the roof and.
So how does it protect the house from water might come in the hole?
Oh, I know that the licensed contractors ensure that all the appropriate sealants is in place so that you're not looking at any sort of degradation to your rooftop.
And you don't really actually need to have an attic. You can have an ordinary atticless house, which many houses in Hawaii are.
Absolutely. I was just talking to my friend, also a colleague at Hawaii Energy, and she has the same thing, and it vents right into her living room space. So it is, called a solar attic fan, but it is specifically for, drawing out the warm air from an open space. Typically, attics have the highest heat, when you have that
It
space.
sounds like something everybody should get, honestly. I mean, because, the most uncomfortable part of the year in Hawaii is when it gets all hot and muggy, and all you need to do is get that hot air out of your house,
Right.
and you feel so much better.
Right.
So, so they could call you for a list of possible contractors?
we can help. We can set them up with a recommendation for folks that do offer this as something they sell and install. And beyond the solar attic fans, we also offer a rebate for whole house fans, which work in conjunction with cooling your house. They're vented through your home. These do require electricity, but they allow you to draw in all the cool air from the outside and pull it up out of the house. So when you turn on your AC after that, the house is much cooler to cool down. So we offer a rebate for those as well.
Bigger rebate for
Bigger,
that. There's
bigger.
more money involved.
Yes,
in those
that
things.
is correct. It is more, yeah. So this is a $75 rebate. But again, similar, we have a list of contractors we can put you in touch with if that's something you're interested in installing.
Perfect for a summer discussion. Carolyn.
Absolutely. So.
Okay, anything else? Or
Oh, absolutely. So for those of us that are lucky enough to have a pool, we do have rebates for energy efficient pool pumps. So everyone knows if you have a pool, you need a pump, but you may not know what type of pump you have on there. So you want to take a look, because conventional pool pumps run at one speed all the time. Well, there's higher efficiency pool pumps, variable speed pool pumps that that actually modulate, so they're not running full speed all the time. And we, guess what, offer a rebate for that as well.
just being smart, clever, that's
Yeah.
what.
Yeah.
How much is the rebate on that one?
$150.
Okay, that means it's more expensive, eh?
It is, yeah. Right now our average pricing is a little over $1,000 that we're seeing for
Yeah,
instead
okay,
of
but there's a lot of energy involved,
Absolutely.
and a lot of energy could be saved.
a typical pool pump uses about 20% of the energy in the home, so you can reduce that significantly by installing the variable speed pool pumps.
Okay,
Yeah.
have we come to the end of it?
I can
For
give
today?
you for today. I'll
All
be
right.
back with more very soon.
All right,
But
promise me.
Oh, absolutely. Always. But you can always give us a call at 537-5577 or visit us at hawaiienergy.com for more information about both our residential and our commercial rebate program.
Carolyn, it's terrific. The Negawatt moment is going better and better. You guys, are very skilled at it. You're talented, you're interesting, and you can answer my questions, which is something. Thanks for coming
For
down.
now. Thank you very much.
Okay, aloha.
Aloha.
We're going to take a short break, and then we're going to get back to Greg Wong. And by that time, we have information that makes us believe that Ray Starling will be joining us at the table. I think I see him now. Be right back. I'm Jay Fidell. Come and watch Agritech in Hawaii on Mondays from 4 to 5 p.m. We'll introduce you to farmers, agricultural officials, agricultural experts, and academicians. You'll learn about agriculture, which is very important in Hawaii. Come and watch us.
I'm Hong Jiang, host for Asia in Review on Tuesdays.
And I'm David Day, host for Asian Review on Thursdays. Both of us broadcast our respective shows at 4 p.m.
And my topics tend to deal with questions related to environment, culture, history, and sometimes human rights.
And my shows tend to be on international business, foreign policy, geopolitics, and national security. And you can watch our shows live on the ThinkTech website at thinktechhawaii.com.
And you can also watch us on YouTube or Olalo.
So come join us on Thursdays at 4 p.m. I'm David Day.
And on Tuesdays at 4 p.m., I'm Hong Jiang.
Aloha.
Aloha.
Hello, I'm Martin Despang, and I'm the host together with the one and only Ali Yamashita, and our show is called Urban Transcendence. And Urban Transcendence is about identifying where we have a unique situation of a vibrant city in one of the most beautiful natural environments. So how these two can coincide, sometimes conflict, how they could find reciprocity in the 21st century is what we're excited about. And we're planning on bringing in a diverse body of guests, both from the arts and the science and the established and the wise and the emerging generation. So hope you will join us. We'll always be on Thursdays from 1 to 2 p.m. Thank you.
Okay, we're back. We're live. This is Wednesday, and therefore, ergo, may I say, ergo, it means Hawaii, the state of clean energy today. And as you will notice, Ray Starling is now at the table, joins us as a host. So we now have two hosts, and poor Greg Wong is in the middle. Okay, I'm talking about HSWAC. That's the Honolulu Seawater Air Conditioning. And we're talking about cooling our buildings with HSWAC today. So the first thing is, we've been talking about and looking at and sort of, testing on possibilities. I mean, this technology has been cooling and providing air conditioning services for NELHA for 20 years, you know. And it's been discussed downtown for at least, what, 10, maybe more. So here we are today, 2014. You guys, last time I looked, you had most or all of your permits, and you were ready to do some dramatic things down Alakea Street. So how about a status report, Greg?
Yeah, mostly right about permitting. We have most of our permits. There's a lot of permits for a project of this nature. You know, mostly we're in city streets, we're in state streets, we're going out in federal waters. So if there's an agency that gives a permit, we probably talk to them or have a permit from them. We are still waiting to get our final federal EIS. We see the light at the end of that tunnel, which was a very long process. So that's good for us.
How many years?
Almost old as me, but no, I think it's on its 7th or 8th year through the process.
This is a great country. Oh, wow.
Yeah. The state EIS went relatively quickly because we did do a state EIS as well. And that was done, I believe, back in 2009 it was completed. So that was done. So yeah, that's one of our biggest last hurdles for the permitting process. And really what we're focusing on right now is customer commitments. We've done a lot of the engineering, we've done a lot of the design, so we pretty much know how and how much it's going to cost to build, because that was a big hurdle as well. As I mean, coming in and digging up Honolulu streets isn't exactly an easy task, and being able to do that as a private company, especially not an easy task. So we have all those plans in place. So we're pretty much ready to go there. Contractors are ready to, quote unquote, start digging. We just got to write them a couple checks. So,
But it's a moving target. I mean, you could, if you tell a contractor in, say, the year, I don't know, 2010, that you want him to do a certain thing, and then tick, tick, tick,
Yeah.
4 years go by, he's not ready to do it at the same price.
no. That's part of the challenge with doing a project of this nature is to getting all the pieces, because there's so many pieces that need to be fall into place in the right timing and timing together. So really right now what we're focusing on is our customer commitments, because we're project financed, it's going to be paid for by the customers. There's not a single like utility or government agency that's going to pay to build this out and then let the customers come. We need a certain level of commitment from those people who are going to use this system over the years to actually pay for it. So that's a challenge in itself. We have
What does that mean? I mean, are they going to actually give you the money that you need to meet your budget and do the construction?
No, actually what it does mean is that they commit to paying for the service for a certain number of years.
And then you bank that.
And then we bank that, exactly. So it's kind of like when you go and pull a 30-year home mortgage and the lender looks at your credit score and how much money you're making each year. So we need those kind of assurances that we're going to make our money over the years and providing service.
On the state EIS, does that have a termination date or a cannot exceed before you actually have to be using
It did in Turtle Bay, but it was like 20 years. You know?
Okay.
Yeah, it's a good question, Ray. I don't know.
Yeah.
That hasn't been something I've been aware of, so I'm guessing it's not something we're up against imminently, but yeah, I'm not sure. I wasn't part of the EIS process.
I think that when you're talking about only a few years, how long has it been? It's been, what, 3, 4 years?
2009, so 4 or
Okay,
5
so
years.
5 years.
It's getting up there, but
They should be understanding, actually.
Yeah, that's not long.
It's not like you're
That's
taking
not
your
a long
hand off the
time.
stick. You've been
Right.
trying every day.
for sure that's a challenge with the permitting issue because some of the permits do have shorter time horizons than others, and trying to get those lined up so that you don't have some lapsing and
Yeah.
some don't, or some are still waiting. So I know that is a challenge for us, and renewing permitting and making sure that we don't let one lapse, because when you got so as many as this project has, it tends to you get something, you put it in the file it away, and 4 or
Yeah.
5 years
Oh,
later
yeah.
it comes up around again. And
Yeah.
So you sort of have the critical mass that has to come together all within a few moments, if you will, in time, or months in time.
Well,
so-
Ray, I mean, you're alluding to a major problem in terms of development in the state. We can respect the environment. We can respect all the interests of all the constituents for all the agencies. It still takes too bloody long to get a thing going.
It
I mean,
does.
this
It's
is a
very
long
difficult.
time.
It's well known that it's hard to have a business in Hawaii just because it's difficult, it's expensive, and the permitting, especially if you're going to be digging up streets and those sorts of things that put you in different regimes for getting EIS, permits, and all of the other things that have to come together. It's tough.
I think it was actually written in the Bible, in the book of Job.
Is that it?
Yeah. Well, anyway, I mean, this is, I mean, you hear these stories all the time about various, the bigger the project, the more the permits, the longer it takes, and the harder it is to coordinate the permits. And then, I don't think it applies in your case, but there's one situation where you have to have something from the state government that says you got all the permits. You have to have permits saying you got the permits, and that's really tough to get. So, anyway.
Yeah, and it works both ways because it's risk for everybody. And our customers, and like I said, right now we're up against where we need a certain level of commitment from customers, and as a customer, they understand that there's quite a bit of risk from a developer to actually getting projects completed. So,
well, let's talk about that. I mean, we know that the difficulty with seawater air conditioning is it replaces the chiller, and on an office building, the chiller is going to be worth a lot of money. Replacing it's worth a lot of money. And so like Ray says, you got to hit it at the right moment in the continuum was the word we talked about.
Yeah.
And so for example, if the landlord has just put $1 million into a chiller, he's not going to be really intrigued about putting seawater air conditioning in there because he's already made his investment.
Not right now, but come see
They
him.
need him now. They need him at a moment in time. Nobody can wait on this. They've got to get, as you said, their critical mass together. I mean, what do? You tell a landlord, hey, hold up on that chiller. But he may or may not hold up on that chiller.
Yeah, that's a challenge for sure with this project as long as it's taken for us to get to where we are today. We talked to some buildings where exactly that issue was an issue 10 years ago when we first started looking at this is, hey, I just invested in brand new equipment. I'm not going to willing to walk away from that. And then almost in the same light because it's taken so long to get to where we're at today, now they're almost in the other end of that spectrum where they're saying, hey, I need new equipment now. I can't wait for you because you're another 2 or 3 years down the road.
It's true. You've been through one useful life of a big chiller already.
And that's one of the advantages of this program. District cooling in general and district heating and district energy is you kind of get out of that cycle. I mean, it's just this never-ending cycle for property owners to maintain some of this equipment. And it is a struggle when you're looking at introducing something new, especially like this. But we see that as a huge advantage for once it is implemented for a property owner, they don't have to worry about those equipment cycles because that is probably one of the largest pieces of equipment and it's never ending. I mean, you buy it new, you have a couple honeymoon years where it's under warranty and operating, and then problems are going to come up no matter what, and then eventually you're going to be up against that decision of replacing it and big dollars and okay, is now the time? Do I wait? Or so. It's kind of a never-ending cycle, and we've had to work through that, introducing our product for sure.
So from a, I guess a planning point of view, what kind of arrangement can you have with a building where you don't know exactly when you're going to start, and they don't know when you're going to start, and so but what you want to time down because you need to time down to bank the income stream from the program. What do you say to them? What kind of agreement is that?
Well, the simplest way that we look at it is that over the life of our service or the life of a normal chiller life, say 20, 25 years, whether you just bought your chiller today or you're going to buy it 10 years or 25 years down the road, over a life cycle cost analysis, it's going to pencil out that you're going to save money. Whether you just bought your chiller and you're going to hook up with Honolulu Seawater Air Conditioning or a seawater air conditioning type service. But most people have a shorter time horizon. They're looking at 1 or 2 year increments. So it is a challenge, and there is ways to overcome some of those, whether it be deferring cost, recognizing that money is going to be spent later, and we can take payments later down the road to offset some of those things. But I don't think there's one solution for everybody. Each property owner, each building has its own.
Is that your way of saying that the contracts with the buildings are different?
Yes.
And the negotiated terms, the economics are different.
Right.
You
see right through my.
Listening to the buzzwords here.
the original concept when we came in was everyone wants the same deal because everyone, you're going to look to your neighbor across the street and say, hey, they're getting something different than me. And that's the way some of these programs are set up, is that costs are the same across the board. Everyone shares costs, and that's the way we kind of structured this to begin with. But then going out and actually going out and selling the product, we realize that people have different needs, even though it's all about cold water at the end of the day, but financially it doesn't work for everybody the same. So we've since restructured and said, okay, we're willing to work with you because each property is different, and everyone eventually is going to pay the same, but it's
From your end, yeah. It's
Yeah,
going to net out the same way.
right.
But from
not all
their point of
customers
view,
create
they
equal.
have their own expectations and demands. So
Right.
it's almost like you begin the negotiation by saying, well, what would you guys like?
Yeah, and that's what takes a long time because most people with air conditioning, right, you might be experiencing this, but I think a lot of people, they don't really know what their air conditioning really is all about. They have it in their building. You go buy your chiller and you buy this and you have your engineers on staff to operate it, but there hasn't been such a different alternative than Honolulu Seawater Air Conditioning in the past. So when you're really forced to take a look and see, okay, what is this that I have, this air conditioning thing that I have, it takes a long time to get educated as to what it really is.
Sure, and as soon as you educate the building management, then new management comes in.
Yeah.
And then you have to educate them.
Yeah, that's not
That's
too
true,
far
and
from the
there's a
truth.
cycle where people sell the buildings,
Mhm.
and
Good
so
point.
if you catch them at the wrong time, it's not ready.
Well,
It's
yeah.
not ready to pop. So to
And the
speak.
problem is when a building is being sold, they're not thinking about expectancies. They're thinking about what contracts are in the drawer. What leases are in the drawer. What are your assets? What are your liabilities?
sure.
Don't tell me about visions. Tell me about what's in the balance sheet. So they're not going to care, and probably the new management is going to make a new decision all over again.
Yeah, and we do have the opportunity to be working with several different types of customers. Like ones we're talking about right now are sort of the commercial real estate properties, but within our district we have local state governments, federal governments, condo associations,
And
utilities and
some
hospitals.
of the government agencies have publicly said that they're going to join, right? Or did I?
Yeah, well, we have the federal building
The
signed
federal
on.
building, okay, yeah.
Signed?
Yes,
I
yeah.
forgot
That's
whether that was
something.
out yet officially, but yeah.
Yeah,
Okay.
the federal building has agreed to become a customer. And just from our standpoint, working with a federal contract, our standard contract definitely does not fit into a federal contract. So, that took a long time for us to sort of massage everybody's sides and
How do you get by,
Get it to work.
procurement requirements and all that?
I
Sorry, I asked you that.
yeah, it took a lot of telephone calls.
Okay.
But because it's a unique product for them as well, utility product, it's a little bit outside of the normal procurement box.
Yeah, there's not like a lot of competition right now.
Yeah. I mean, so yeah, it's I'm definitely no procurement expert, but it took a lot of work, and similarly with the state and city governments, we're working with them to, make the product fit with what they can procure and within their rules.
So,
and
I mean,
regulations.
do you have a number of buildings pinned down? I mean, I'm happy to hear that you got a federal building, but, do you have contracts going on? I mean, where it's like signed?
Yeah.
And they're obligated to come along with you the minute you turn it on?
Yes, we have signed customers. We have a limited area of service, right? I mean, one of the challenges with these projects is you can't just kind of circle the whole island and say, we'll
Yeah.
go wherever,
Right.
whoever wants it.
Not yet, anyway.
Not yet. Maybe one day. But so we kind of circle our little area of downtown, a little bit of Kakako, and say, okay, we know the customer base there, and this was done 7-8 years ago when the first projects first started going on, and made contact with all those people. And the initial interest was all there. It continues to be there, but now we're at varying stages of contract negotiation or education of the product, and obviously some are more interested, others are taking maybe a little more wait and see approach.
I can understand a lot of buildings can say, Greg, when you got it all in a little package with a bow on the top, give me a call.
Right.
And,
Our contract isn't that thin. It's not that thick, but it's quite lengthy and takes some time. It does take some time and effort from both sides to get through it. So it's not an easy product.
That's
you know.
probably another building calling you.
Yeah, right.
You want to sign up. Yeah.
Well,
You better take that.
Let's take a break, okay? This is ThinkTech Hawaii. Today, Hawaii, the state of clean energy, because it's Wednesday. The guy on my far left is Ray Starling, co-host, and the guy in the middle is Greg Wong, and he's with Honolulu Seawater Air Conditioning. We're talking about cooling our buildings with HVAC. We'll be right back. I'm Jay Fidell. Come and watch Agritech in Hawaii on Mondays from 4 to 5 p.m. We'll introduce you to farmers, agricultural officials, agricultural experts, and academicians. You'll learn about agriculture, which is very important in Hawaii. Come and watch us.
Aloha, my name is Willow Chang Alion, and I host a show called The Art of Life. We air live every Friday from 2 to 3 p.m. And what we do is basically we focus on individuals who create a unique sense of place for Hawaii. These are movers and shakers, artists, innovators. They are also traditionalists. They're all involved in the archival process, and they make this place a unique place, one that makes Hawaii a richer place to be. I hope you do join us, and certainly tell your friends about the show, whether they live here or they live abroad. It's a way to give back to our community. We're keeping it Pono.
Okay, we're back. We're live. We're here, ThinkTech. On Wednesday, Hawaii, the state of clean energy, with Greg Wong of HSWAC, Honolulu Seawater Air Conditioning. Ray Starling joins me as host. We're talking about cooling our buildings with HSWAC, and we're sort of getting a status report on how that is all doing. So, make me a building. Poof, you're a building.
Sure.
Make me a building, and here I am. Give me the vision of what this is going to do for me, why I should consider this, and at the end of the day, how much money am I going to save, or shall I say, how much money are my tenants going to save?
Yeah, Jay, most times the focus is the savings. Obviously, this project isn't free for us to build, so there's considerable cost to becoming it's not a zero-sum proposition for
100
property.
million?
North of 300
Oh,
to build.
oh,
Well, I mean, our construction costs are about 250 million, and then we have some other development costs. But the beauty of the seawater system is the voided electricity, and what that does for you is you switch out your energy models from this volatile market that we've been in with HECO. I mean, everyone's trying to keep their costs under control through all kinds of measures. But at the end of the day, it's still a volatile market. Something could happen tomorrow and costs could go up again. We saw some pretty steep increases in like 2011 or so, where we had 30% increase in a year or something.
Mm-hmm, yeah. If that happens, though, I mean, if that kind of thing happens, they're going to be beating a path to your proverbial door.
Right. I mean, for good or for bad, right now at today's, whatever a building's paying, about 34, 35 cents a kilowatt hour, we're kind of right. The savings is almost marginal. It's moving around a little bit.
Yeah.
So if we were at 40 cents a kilowatt hour, 45 cents a kilowatt hour, the savings goes up considerably because we have our costs are pretty set in the construction of the project. So the real advantage to our system is stabilizing, offering a stable piece of your energy costs. I mean, air conditioning, we estimate, is anywhere from, on the low side, 20 to the high side, 40 or 50% of your energy bill goes to air conditioning a big building.
So for a kilowatt hour, what? It's cutting it in half then.
Right. I mean, it's not cutting your costs in half, but what it does is you've diversified your energy portfolio. You use a sort of a stock portfolio analogy, right?
Yeah.
You're no longer vested in this highly volatile HECO market where, we could bring in LNG, we could bring in wind, we could bring in solar, costs could get pressed down, but what if something else were to happen, the costs were to go the other way?
Now, this is only going to affect air conditioning. It's not going to affect any
it's only going to
other
affect air conditioning.
electrical service
right,
for the building.
Right. So there's still quite a big chunk of energy there that's still in the HECO market that can we don't affect, but you really are switching out a model where you're paying HECO for all of your energy to a model where you can be paying a substantial amount of your energy.
Well,
to,
and
to a
I
fixed
speak
cost.
of downtown office building. They use, I mean, air conditioning is really important.
Right, right.
And these firms, I mean, in a closed building where you know the windows don't open,
Mm-hmm.
you'd better have the
yep.
air conditioning on there. Or you're going to be in trouble with your tenant.
All right.
And so it's an important part of the, you know, the product that you're offering these
Mm-hmm.
tenants.
Yeah, and another benefit of our system is we're on 24 hours a day, 7 days a week. Some of the strategies for buildings to save energy is to turn your air conditioning off. You know,
Ray
if
will
you try
tell
to
you
come
about
and work
that.
on Sundays, you know, there's no air conditioning.
Yeah.
Air conditioning hours might be getting shorter, or Saturdays are getting cut, you know, to try to save a little bit of energy. But you know, what would the building product be if you could run it 24 hours a day, 7 days a week? I mean, could you have people working in your building all night on the weekends?
But you still have to have electrical energy to run the fans, right? And the blowers.
Yeah.
It's just the chill water, but the chill water is a big percentage.
Yeah.
Do you have a number for me about if I take an air conditioning system, okay, and I'm using X percent for the chill water,
Mm-hmm.
and I'm using Y percent for the fans and blowers and all that stuff? How much of the total is the chill water?
So DBED did a study of office buildings in Honolulu or in Hawaii, and their number is about 35% for the chillers and the cooling towers, the electricity there. The fans, I can't remember exactly what the number was. I don't know if you know, Ray, is it
I don't. It's-
30 or another 20 or 30% just for the fans to circulate the air, something in that frame. I'm more concentrated on the chiller and the
Sure.
cooling tower number.
Yeah, the chillers and the cooling tower are the big draw.
Mhm.
Yeah.
So where does Hawaii Energy fit in this? I surmise there's a place for you, right?
Yes, there is. In fact, even before Hawaii Energy came into existence, the PUC had already established that they were going to allocate funds for seawater air conditioning. Remind me, is it $300 a
Per ton. Correct.
Right, $300 per ton, and that's a substantial amount, and that is
On
that's
installation.
there.
On installation.
Yes, whenever it goes into a particular building, then the $300 per ton installed would be given to the.
So
To-
we don't
well-
know what a ton means. I mean, for say a one block office building downtown, how many tons?
I'd say the average office building downtown is about 500 tons.
So
So-
I can't do the math. It's too late on a Wednesday. But that sounds like $150,000. No,
Yeah, it would be the rebate from Hawaii
it's a
Energy.
substantial rebate. So that's an encouragement to the building owner. I mean, has it worked? When you tell them this, Greg, do they start salivating on their shoes?
It helps. It definitely doesn't hurt. It's not the. It doesn't answer everybody's questions because there's still quite a bit of cost associated with subscribing to the service. So all those costs have to be vetted out and everything. But it definitely does help ease the blow of, like we're talking about
It's
earlier.
a sweetener. The rebate program is designed to do that. On certain rare situations, we will rebate 100% of the cost. Usually for small businesses, lighting. That's a program that's ongoing now. But on most of all of the other rebates that we give, we couldn't afford to buy 100%
No,
for
I mean,
everybody.
you can't.
So we do something less than that. Generally, on average, it's around 25% of the total cost is rebated. And that pushes people over the edge to go ahead and do what we want them to do. And they ultimately save lots of money after doing it, but you need to get them to jump, right? And that's sort of the reason why there's a substantial rebate on these the product and the services that Greg is going to be serving.
But this is the other element to that, and I think it goes directly into the model for Hawaii Energy, is that it's a nod. What I mean by that, it's a government nod or an official nod. And what it's saying is this is a protected activity. This is an activity we, the government who
It's a good idea.
presumably knows about this, a good idea. You should do this. We're with you on this. It's not fly by night, it's real. And when you say that, I mean, it's more than just the money, and it's more than just the economic incentive. It's a sort of philosophical thing to say you're in the right, you made the right decision. For the executive, you know, who doesn't want to get criticized with making a decision, that it's a loose decision. This helps to defend his decision.
Right.
And that's an important point, Jay, that the rebate is actually for all seawater air conditioning projects, not just Honolulu Seawater Air Conditioning, but if another project were to develop, then they can take that same rebate. So.
Well, so I want to go down that trail. There's a pipe.
There's a pipe, lots of pipe.
The pipe is out beyond the medical school,
Yes, Kaka'ako is our intake pipe.
and it goes how far out?
It's about 4.5 miles long.
Oh, wow.
It's about 65 inches in diameter, so you could basically walk through the pipe.
That's taller than I am.
Yep.
Oh, wait a minute. Yeah, it is.
It's a big pipe, and it's will be deployed in about 1,750 feet of water. to
Now,
suck in the
now is
water.
the shelf out there at the reef, this would be, where would this be? This would be not Point Panic, but closer to downtown.
Yeah, closer to downtown
Foreign
channel.
trade
comes out.
zone there.
Yep.
Yeah.
Yep.
And so
Medical
it
center.
goes along the reef, I guess, relatively flat. It gets out there 4.5 miles, drops 90 degrees. Is that?
No, the top bathymetry out there isn't quite like that. It actually drops quite fast after you get out about half a mile offshore. So it takes a pretty steep drop, and then it gets a lot more gradual slope. So it's definitely not one of these. We would love it if it was a 90-degree drop and we can get as deep as we wanted to. We would be able to save a lot more energy than what we're looking at.
Now, what's the comparison between the pipe they try to use for the medical school? They try to do this for the medical school,
That's a
but they
different
couldn't
process.
get far out enough or something.
That
right?
one they dug wells straight down.
Yeah, straight down.
Right at the coastline. Yeah.
Right at the school. So
But, yeah, they were staying in the ground.
yeah,
basically.
vertical.
Yeah,
They were
that
not
didn't work because they couldn't get it cool enough. Yeah,
Right. The
Yeah.
plan was to pull up
Mm-hmm.
water of a certain temperature.
and they just couldn't get. You have to get way deep in order to get the temperature difference. Yeah.
Yeah, I mean, not a geologist, but when you drill straight down through a landmass, what kind of water you're going to get, I think it's a little different than when you actually go out to the source and you're pulling it from where you know the temperature.
You are an engineer, I know that. You're not a musician.
No, I'm a pretty bad musician. I try, but
Okay, so then that was, and that didn't really work. I think it worked in part for the medical school, and they had to bring in old-fashioned electrical power to do the rest of their air conditioning. But this, and you learned from that because you saw what happened. This is back around 2002 or 3 with the medical school. As I recall, it was after the school was actually finished, and they were sort of trying to get everything together, and that was a loose end. So now, having learned from that, you're going to be able to get water that's sufficiently colder.
yeah,
And you need to get it because the landlords require it to be a certain temperature on delivery. This is a big issue. And you have got to find a way to get them that temperature because they're going to want a guarantee from you about exactly how. So how cold do they want it? How cold can you promise it to be?
our product is relatively simple, I like to think. It's just water that's been treated
Fresh water.
fresh water, not salt water. We deliver you fresh water that's 44 degrees Fahrenheit. That's it.
Simple enough.
Simple enough.
Yeah.
But
How do you get it that
How do
cold?
we do that? The water that we'll be drawing up, the actual seawater, hovers right around 44 degrees. We've been monitoring it over the last years to actually see what it is. It has a little bit of variability through the season and tide changes and whatnot, but basically we'll get it up to our station about 45 degrees. It runs through a plate and frame heat exchanger, so it's a big radiator. We transfer the temperature in between the seawater and our fresh water. That will drop it down.
And your fresh water is a closed circuit.
Closed loop circuit, yeah. So there's no contaminants getting in there for corrosion or
right, important,
stuff
yeah.
growing in it. Very important. And then we don't get it cold enough, unfortunately, to then deliver straight to the building. So what we do is then we'll pump that through our own chillers. So we actually do have chillers at our cooling station, and those are just for what we call quality control because we can't
Make
be
sure you
sending
get up to the
buildings.
44 or
Right.
down to the 44.
Right.
Yeah.
So we'll chill it down another couple of degrees, then pump it out through our distribution pipes to the individual buildings.
So you talk about corrosion elements, with caustic seawater and all that stuff. And so the loop that goes or will go up and down Alacair Street will be fresh water.
Yeah.
And it won't have those contaminants. But what about the seawater pipe that goes out 4 miles, and comes back into the exchange? I mean, that's going to have seawater. What happens there?
Plastic.
Plastic. Ha!
I mean, it's not the best
That's
engineering
plastic,
word,
young
but
man. Plastic.
so I'm not sure what the final design is going to be, but it's some plastic pipe that won't be susceptible to corrosion from seawater.
Brilliant.
Yeah.
Try to use steel and see what happens.
Concrete collars are bolted on, so there is some steel that bolts these concrete collars together. Actually, the pipe
Hold
is
it
weighted down.
Yeah.
It's and then there's some sacrificial anodes that are attached to that. If there is anything that can corrode, the idea is that you prevent that. But the pipe is very robust. I mean, even if you were to spring a little leak here or there in warmer water, we'll still be getting our 65 inches of seawater from our targeted depth. So
Well, in a project like this, you really have to build it
beefy.
solid, beefy, because I mean, just explore that, and you probably have other systems that will protect it. But if you are the landlord of a building, and one day the chilled water fails, whatever reason, your tenants, half of whom are lawyers, and who have certain personality traits, are spilling out, of the buildings. And
Trust
as
him, he
they
knows what
spill
he's
out,
talking
they're
about.
drafting pleadings already about all the damages they've
Yeah.
suffered because they can't do business in their law office and all that stuff. So how do you deal with that? Because this, the threat, although the risk may not be that great, if it happens, the threat is great.
Right. A lot of work has gone into designing the reliability of the system. I won't get into all the details, but typically a district energy system, because these are all in place around the world, the reliability is much higher than a typical, what we call on-site, if you're to be running your own equipment. So 99.999% reliability. And those numbers usually include scheduled downtimes for repairs or adding on people to the system. So
I hope it's 2 in the morning.
yeah.
Like that they should fix the traffic problems at 2 in the morning also, but they never do.
So that is one of the advantages of the system, is that since we're servicing buildings that are usually closed after hours, and there's opportunity to service parts during when people aren't using air conditioning. So, but yeah, the reliability of the system is paramount, and currently with the systems that buildings have, there's a level of risk. Equipment failure. Usually you have redundancy built in, but even then, you can have problems. Hawaiian Electric, they do have every once in a while, they have power failures, and that's the main driver for these systems. So we'll actually be able to deliver, even without HECO, we'll be able to deliver chilled water. So
You need electricity too, though, to pump the water, right?
Right.
In order to
Right.
pump it up Alacair
Yeah.
Street, wherever you can put it, you have to have
we still
pumps.
require electricity.
And you have to have this. Where's the exchanger going to be?
Right behind the Gold Bond building, 677
A separate
Ala Moana.
building.
Yeah, we're going to build a separate building. It's about, our footprint's about 25,000 square feet of space. So it's a very small
Right
footprint.
next to Ilalo Street there.
Is
Or on the
yeah,
Mauka side of Ilalo.
on the Mauka side, yep. So there's like a lot that they park cars in there right now. It's kind of a dirt lot, so.
Okay, you're going to let the artists paint the side of the building?
I don't know about that.
You don't
Supposedly
have to
there might be a
commit. It's
parking
a-
garage above it, so it might be not a whole lot of building to be seen. But
Sorry, Ray, you had something.
No, I was just going to ask you. You say you're going to deliver the water to each of the buildings at 44 degrees. What do you expect the return temperature to be when they give it back to you?
yeah, we need a certain level of efficiency in the buildings, and that translates into what the temperature returned at. So we require 54 degree water back, so it's a 10 degree delta T that we were looking for, and that's pretty common for the design of the downtown
Okay.
buildings. Some of the European systems actually require a 16 or 18 degree delta T, meaning that the buildings have to run even more efficiently. So it depends on your delivery temperatures too, but thermodynamics is one of those great sciences where you can pull efficiencies from a lot of different places, and we offer incentives to be efficient as well, kind of like similar to the electricity efficiencies.
Right,
If you're
right.
more efficient with our system, because we have free cooling from the ocean, but only to a certain level, we do offer incentives to properties if they can use our cooling.
So what does that
More
mean?
efficient.
Suppose they come back with water that's 60 degrees. What are you going to do to
We
them?
actually give them $1 rebate on their.
If they come back at the right
Correct.
temperature.
If they come back at a higher temperature. If they come back at the right temperature, the cost is what it is. So, but if they come back more efficiently, we'll actually give $1 incentive. Based on
That'd
how
be a
much-
lower
Now,
temperature would be, okay.
do you, in terms of talking to a customer, potential customer theoretically doesn't have his mechanical engineer right
Right there,
by
yeah.
his side.
Sure.
So when you're talking to him, do you attempt to help them understand what they can do to enhance their the cost effectiveness of what
Yeah.
what you're selling?
Yeah.
And what can you tell us what is on their side that they have to construct in order to plug into your
Yeah,
system?
right. Part of back to the question of how much the rebate is it's sort of a fixed number because each building is so different. You know, some have their chillers on the roof, some have in the bottom. So it's not necessarily that based on the size of the building, this is your cost to convert. Some is easier. You know, we just poke in through the building wall and we can hook up. Others, we're going to have to go up to the roof, and a 20 or 30-story building is not as easy. But basically, if you think of a plumbing system, you know, like a sprinkler system that you might have in your yard even, it's just, we just plug into that existing loop that they have basically, and then we can supply water directly to their system, or in some cases where the building's taller, we have to actually physically separate it with another heat exchanger. But it is just plumbing. It's not overly complicated in the sense of technical aspect. It does take a little bit of creative thinking sometimes to
What about
find the
pressure?
best
You
way.
have to deliver at a certain pressure too.
Yeah, and we deliver at a certain pressure, so we'll be able to pump our water through a lower building.
What is that?
It's 150 psi.
Okay, and that's not going to carry it to the top of a skyscraper.
No.
Because they're going to have to
yeah.
get their own pump to
Right,
deliver it to
right.
the top. Yeah,
Well, they do now.
yeah sure.
Presumably.
They probably have that already, so
Yes.
no
Right.
sweat. Oh, well, I guess, you know, the question I would go, and this is something that I'm sure Ray's thought about, is so you have to be efficient. I mean, the building has to be efficient in order to, you know, get the best rate, so to speak, and get it back to you at a reasonably cool temperature. So what can a building do? What must a building do to achieve that efficiency? How do I make my building the best it can be
Yeah.
to get the best rate out of you guys?
Well, just the benchmark is most buildings will be able to just plug our system in and use it, and it won't be any different. Where they'll start to look for efficiencies is in the pumping. Some of the incentives you already give for variable speed pumping to maximize the temperature being exchanged between the air handlers into the air and the water. There's coil upgrades that buildings can do in the actual, what they call the air handlers or the fan coils that actually exchange the water.
Equipment
The equipment,
upgrades.
equipment upgrades in the building.
What about tinted windows? Does that
Um,
help?
That will help lower the actual cooling load, but as far as increasing the efficiency, it doesn't necessarily apply to
What
that.
about buildings? I was in a building today, a downtown building, and the front door was open. I mean,
Sure.
wide open.
Yeah.
And as you walked in the building, you felt,
Cold
Ray,
air.
you should have been there. You would have given them a ticket or something. I'm not going to tell you what building it was. The cold air is piling out into the street in great gusts of cold air, and saying, this is costing somebody a fortune. Does that matter to you?
Yeah, I mean, anything the building can do to be more efficient with their air conditioning energy, it will result in lower cost from our side as well. So,
Well, I mean, I think it's really important that you are encouraging efficiency by giving them a better rate if they deliver the return water at it.
and that's one of the challenges for like you say, when you speak to an owner. I mean, there's so many opportunities to make your air conditioning more efficient, whether you have a window shaker or you know, the most sophisticated cooling towers and chillers, centrifugal chillers. I mean, there's endless amounts of way to make your current or future air conditioning more efficient and save money. So there's endless ways and opportunities.
So I have one
We're
last
just one piece of
question
the
for
puzzle.
you before Ray does our summary. You know, that's a double question. where is this going to go from here? In other words, you know, when are we going to reach nirvana on this? And what is past nirvana? In other words, so you have a federal building, you have a number of buildings, and I guess in Kaka'ako and also in the downtown, you know, high-rise area. How is that going to unfold? And the second part of it is, you know, actually, why do I care? Why do I care what happens? I don't care. Do I care?
Yeah, you do. You do
Okay.
care, Jay. Well, on the short-term horizon, we're poised to start construction. Like I said, we need customer commitments, and that's sort of our last critical path item. Once we have that, we feel like we can start construction early well, what's our schedule right now? Next year, and it's about an 18-month construction time frame. So seawater air conditioning can be a reality within 2-3 years for our system. Next up would be Waikiki is an obvious target, though it's going to have its own challenges with construction and customers as well. I mean, it's just a long process.
Waikiki. We're not talking about Waikiki now, though.
Yeah, no, I mean, Waikiki now can handle a system. It's just
There's nobody building a system for Waikiki right now.
There is another group that's looking at it. We don't really know. You know, we're concentrating downtown.
Are they getting permits? Are they doing what
I
you're doing?
don't know what stage they got.
We
got to
get them on the show, Ray.
stuff, but
Yeah.
they're looking at it. You know, we're focusing on downtown. One of the things with seawater air conditioning is it's going to become more and more viable as energy costs go up. So, because construction costs will stay where they go, you know, they're going to increase a little bit. But if energy costs were to skyrocket, you know, you could possibly see seawater air conditioning in single-family homes just because it's a competitive cost.
If you can deliver, if they're close enough to the water.
Right. I mean, the development costs are really what drives the
pipes.
availability for systems like this
Yeah.
to you know, down to the small markets. Right now, it's not economically feasible to do, you know, smaller structures in a downtown high-rise.
But Waikiki would be a really good
The
target
hotel
for that.
usage.
Anything close to the
Yeah,
the
Pearl
shelf.
Harbor Airport area is another target.
Yeah.
You know, some of the bigger resorts on the outer islands are good.
So why do I care?
Well, number one, this will be a huge chunk of our energy dependence going, you know, from the oil that we've always talked about. Just to give you size of scale, this one project for downtown Honolulu is about 1% of Oahu's electricity usage. I mean, it may not sound like a lot, 1%, but it's, I mean, it's from a renewable energy scale, it's pretty big. If you were to put solar panels downtown Honolulu, we basically cover all of downtown Honolulu to get the same amount of electricity that we're talking about reducing from this system. So just from a pure space size, you know, we don't have enough space downtown to put solar or wind to drive air conditioning the way we're doing it now. So from an energy standpoint, that's huge. But this project and seawater air conditioning project in general, they have other environmental benefits. Water usage goes dramatically, I mean, pretty much goes to zero. Sewage, most people don't usually think about those things when they think about air conditioning. But, you know, those issues are coming. The sustainability of the islands as far as water and sewer and waste is gonna be a new hot topic, I think, and seawater air conditioning can help address those.
Because it's a closed system.
Because it's a closed system, we don't use water to reject heat. You know, we use the sea, the ocean. So there's numerous benefits. You know, reduction of harmful refrigerants that are used now. I mean, there's just a myriad of benefits that these systems can provide, and just a long-term stability of cost of air conditioning, dependability. Right now, we're kind of an unknown factor, but you know, the experience with other systems around the world is that they are, once they're in, they're kind of the way to go. And we think we're just going to be the utility, you know, another utility of the future. When you build a building, you say, okay, I need HECO, where they're going to come in here. I need water for board of water. They're going to come in here, and I need air conditioning from, you know, the streets, and it comes in here. It's not going to be something that, you know, kids of the future are going to know air conditioning as pipes in the streets and not boxes on your lanai that blow fans of hot air into your living room. So.
Okay, Ray, we only have 1 minute left, but what's your whole impression of this?
Well, it's a great idea. It's been a while in the making. I think they're ready for the pieces to come together now and have that critical mass so that once you get it going, it's like a nuclear reaction. I think it will continue. I think you're right. But getting that first critical mass all at the same time is the difficult thing. And you guys are working very hard at it. And we all hope that you will make it sooner rather than later, because we really do need to continue our efforts to reduce the reliance on fossil fuels here in Hawaii.
That's Ray Starling. He's my co-host. Thank you, Ray. And Greg Wan from HSWAC, Honolulu Seawater Air Conditioning. This is Hawaii, the State of Clean Energy, every Wednesday. We're talking about cooling our buildings with HSWAC. Thank you so much, Greg.
Thank you.
Good luck on
Appreciate
this.
it.
Come back and tell us more, okay?
Will do.
Regards to Eric Masatomi,
Yes.
CEO. Thank you.
No, thank you.